Hello everyone, myself Sneha Murthyun, studying in Sri Venkateshwara College of Engineering from ISC branch. The topic today we are going to discuss is discrete mathematical structures, and the topic is cyclic groups and cosets. Here the subject code is BCS405A. The topic is cyclic groups cosets. First is introduction to the cyclic groups. Here, the cyclic groups are algebraic structures generated by a single element. The generator of a cyclic group can be raised to two different powers to produce all elements of the group. Cyclic groups are denoted as A, where A is the generator. Here, some of the theorem is there, that is, a group of prime order is cyclic, and furthermore, any non-identity element is a generator. For this theorem, the proof is let G is equals to prime number and x theta G. By Lagrange's theorem, order x divides G. Since P is the prime, there are two divisors 1 and P. Clearly, it is not 1 because others are a prime number. This is all about the introduction to the cyclic groups and a theorem, and that's proof. Next is the properties of cyclic groups. Every subgroup is a cyclic group is also a cyclic. A cyclic group of order n has elements, exactly n elements. Cyclic groups are abelian, meaning their operation is commutative. This is the diagram of a cyclic group that represents the G is equals to, open the flower bracket, a to the power k, k belongs to Z. So this is the properties of a cyclic groups. Next is applications of a cyclic groups. Cyclic groups are the fundamental in the cryptography, particularly in the designs of encryption algorithms. They are used in error detecting codes and data compression techniques. Cyclic groups plays a crucial role in the study of symmetry and group theory. So first is the cryptography and the symmetric cryptography, asymmetric cryptography. In symmetric cryptography, there are two types. First one is classic cryptography and modern cryptography. In classic, there are two types. First one is transposition cipher and the substitution cipher. In modern, there are two types. First one is streamed cryptography and the next one is online cryptography. So these are the applications of a cyclic groups. Next is the definition of coset. Cosets are subsets of a group obtained by multiplying a fixed element by all elements of a subgroup. Left coset are formed by multiplying the subgroup element on the left, while right coset are formed by multiplication on the right. Cosets partition the group into the disjoint sets with equal size. Firstly, the definition is the cosets are the subsets of a group. These are the subsets of the group obtained by multiplying a fixed element by all the elements of a subgroup. So this is the definition of a cosets. Next is the properties of a coset. The number of left coset of a subgroup H in a group G is equal to the number of right coset. The cosets are either equal or disjoint. The union of all cosets of a subgroup H in a group G is the entire group G. Next is the coset. The definition, let H is less than or equal to G and A in G. The left coset of H containing A is the set that is of AH is equals to AH, that is H in H, small h in capital H. The next is the right coset of a H containing A in the set, that is HA is equals to HA slash H in H. In additive groups, use A plus H and H plus A. A is called the coset representative of a AH. Similarly, AHA inverse is equals to, open the flower basis, AHA inverse H in H. So these are the properties of cosets. Coset representatives. Each coset contains a unique coset representative. Coset representatives are chosen such that they belong to the original subgroups. Coset representatives helps in identifying and distinguishing between the different cosets. The examples of the coset representatives are: first, we have to find a complete set of coset representatives of the subgroups of 19 in Union 56. Enter your answer as a comma separated list. Make sure that each coset representative you entered. First is E is greater than 0 and less than 56, and it is the smallest possible value in this range. That is, if you enter the value A, there is not another value O is less than B, which is less than with B, which is less than A, such that A comma B represents the same coset. Find a complete set of a coset representatives of the subgroup 41 in U50 in Union 50. Enter your answer as a comma separated list. Make sure that each coset representative you entered. This is the second example. For this question, the answer should be is less greater than 0 and less than 50 and is the smallest possible value in this range. That is, if you enter the value A, there is not other value, and 0 is less than B, which is less than with B, which is less than A, such that A comma B represents the same coset. So these are the two examples, and for that they have solved it like this. So this is the representation of the coset representatives. Applications of cosets. Cosets are used in the study of factor groups and the quotient groups. They play a significant role in understanding the structure of the group and its subgroups. Cosets are essential in the proof of Lagrange's theorem in group theory. First is an application of coset to permutation groups, stabilizer of a point. And let G be a group of permutations of a set S for each I in S. Let stabilizer G of I is equals to, open the flower braces, theta belongs to G, slash theta of I equals I, close the flower bracket. Then stabilizer G of I is called stabilizer of I in G. Stabilizer G of I is equals to, open the flower braces, theta belongs to G, slash theta of I equals I. Note, the stabilizer G of I is a subgroup of G. Clearly, STAB G of I is less than or equals to G. From identity permutation definition, theta of I equals I. Stabilizer G of I is not equal to 0, that is non-empty set. Let theta is lesser than theta 2 is stabilizer G be any element where theta 1 of I equals I, theta 2 of I equals I. Consider theta 1, theta 2 of I equals theta 1, open the flower braces, theta 2 of I is equals to theta 1 of I. So this is all about an application of coset to permutation in the stabilizer of a point. This is the application of a coset. Next is cosets in discrete mathematics and security. In discrete mathematics, cosets are used to analyze the structure and the properties of groups. Cosets are employed in cryptography for the key distribution and security protocols. Understanding the coset helps in designing efficient algorithms for the various security applications. This is the picture of a discrete mathematics that is used in blocks and bar graphs, that is an open introduction, Oscar Levin, and this row is Oscar Levin. This row is second edition. This is all about the cosets in discrete mathematics and security. Next is cosets in database management system. In data management systems, cosets can be used to optimize query performances. Using cosets in the database design can improve the data retrieval and manipulation efficiency. Cosets helps in organizing and structuring the data in a way that enhances the system performances. The database management system consists of three uses, that is of applications, other DBMS and users. First is DBMS consists of definition, record, query, update, manage the data, and that is of storage area, relational database, hierarchical database, flat filled database, and the next fourth one. This is all about the cosets in database management system. The next is conclusion. Cyclic groups and the cosets are essential concepts in the group theory which diverse the application in mathematics, cryptography, and the data management. Understanding the properties and the uses of a closed cyclic groups and the cosets is crucial for advancing the research in various fields. Further exploration of the cyclic groups and the cosets can lead to the innovative solution in cryptography, data analysis, and system optimization. Here, they are saying that the cyclic groups are used in the cryptography and the data management and in advanced research in various fields. Further exploration of the cyclic groups can also be used in the cryptography, data analysis, and the system optimization. We have studied the group theory, cosets, definition of a coset, example, definition of index of a coset. Next, the references are group theory and applications by M.J.M. Deza and M. Laurent. Cryptography and the Network Security by William Stallings. Introduction to the Theory of the Groups by Joseph J. Rotman. So these are the references that you can do. Thank you.